Coming to the first question, guys. Work done is nothing but dash. What is the work done according to the physics? Here, work done is nothing but force into displacement. For example, if you have any one body is there, if you apply the force on this body and if it is displaced to any some distance or displaced to any one length, okay, so that is considered as a displacement. So the product of this force and displacement is considered as the work done. So work done is equal to, very important, force into the displacement. Here, if there is an angle between the force and the displacement, if there is an angle between the force and displacement theta, then the work done is nothing but Fs cos theta. Fs cos theta. Okay, so it depends upon the force, displacement, and also the direction of the displacement. Okay, so that is a force and displacement. So the answer is option C. Answer is option C. Coming to the next one, guys. Work done is 0 if dash. When the work done is going to be 0. All of you read all the options. Students, you have to practice the MCQs. Like whenever I have given the question, you have to pass on the question and try to select your answer. After that, check with my answer. You are giving correct or wrong. Okay, so that's the way you have to practice. Here, work done is 0. When the work done is 0, here work done is equal to Fs cos theta. Okay, so whenever this cos theta is equal to 0, then there is a chance of work is 0. So cos theta is equal to 0 when it is happening, whenever the cos 90. Okay, so whenever the theta is equal to 90 degrees, then there is a chance of work is 0. That means angle between the force and displacement is 90 degrees. 90 degrees means both are perpendicular. Whenever force and displacement are in perpendicular direction, then you can get 0 work. So that means if you have applied a force on the object, then the displacement is in the upward direction like this, 90 degrees, or downward direction with 90 degrees. Okay, then cos 90 is 0, so it is nothing but work done is 0 according to the physics. So whenever there is a perpendicular, so body shows a displacement in perpendicular direction to the force applied. If you apply the force here, then your displacement may be in the upward or in the downward. Then there is a perpendicular. Okay, 90 degrees. So the work done may be 0. Coming to the next one, guys. If the body is drilled in a circle, the work done on it is dash. Body is drilled in a circle, rotating in a circle, then the work done is dash. Okay, let us take one body is at position A and it is drilled on a circle, rotating on a circle, and it again reaches to the point A. So it is the initial point and it is the final point. We know very well displacement is nothing but shortest distance from initial to final. Distance from initial to final. This is the A is the initial point and final point is also A. Here initial point is A and final point also A only. So then what about the average displacement? That is 0. Initial and final are same, means 0 distance. 0 shortest to 1. Okay, shortest is nothing but 0 only. So that is nothing but displacement is 0. As the displacement is 0, then what about the work done? F into S. As S is 0, then work done also 0. So it is 0. शून्य is nothing but 0. यदि कोई वस्तु वृत्ताकार पथ पर गति कर रही है तो उस पर किया गया कार्य, that is शून्य. Coming to the next one, guys. Work done by a passenger standing on a platform holding a suitcase weighing 10 kg is dash. Weighing 10 kg is dash. Again, same work done based question. Okay. Here, just now I have given work done is equal to F into S. If there is angle, we have to take the cos theta. Here, a person is just standing and weighing a suitcase. In this case, what is the displacement, guys? He is not moving to any place, just standing. So there is no displacement now. He is just standing means there is no displacement. As there is no displacement, as S tends to 0, then work done is also 0. So the answer is option B, 0. So the answer is option B, that is 0. Coming to the next one, guys. The unit of work is joule. The other physical quantity that has the same unit is dash. Okay, we know the work units are joules. Another one, that is nothing but energy. Energy also having the units are joules only. Joules only. So both are same quantity, same units, energy. Okay, energy is nothing but the capacity to do the work. More energy, more work. Capacity to do work. Okay, more energy, more work. And what about the remaining power? Power units are what? Watt. Or power is equal to work done by time, that is joule per second. Joule per second. Okay, 1 watt is equal to 1 joule per second, or 1 watt second is equal to joule. Watt second is equal to joule. Okay, velocity meter per second, and force newtons. Force newtons. So the answer is energy having the same joules. Energy, urja. Coming to the next one. In case of negative work, the angle between the force and displacement is dash. In case of negative work, the angle between the force and displacement is dash. When the negative work we are getting, W is equal to Fs cos theta. Okay, here negative means the direction constant may be negative. Cos theta is negative. So negative means for cos 180 only there is a possibility. So whenever the theta between, that is angle between the F and S is 180 degrees, there is a chance of negative work. Okay, then cos theta is equal to -1, you are getting W is equal to minus Fs. Minus Fs. So that is possible for theta is equal to 180 degrees. So we can give the answer as option C. So we can give the answer as option C. Coming to the next one, guys. Work done on object does not depends on dash. Work done on object does not depends on dash. Work done formula I have already given, Fs. If there is angle between those two, Fs cos theta. So it depends upon the bulk force. It depends upon the Viस्थापन, yes, displacement. And it also depends upon the angle between the force and displacement. Okay, so angle between the force and displacement. It is also correct. So it depends upon all these three. There is no initial velocity here. So we can give the answer as option D. We can give the answer as option D. Okay, initial velocity. Coming to the next one. 1 joule is equal to dash x. 1 joule is equal to dash x. Joule and x are both are units of work. Units of work or energy. So here work units may be joules, and here 1 joule is equal to 10 power 7 earth. 10 power 7 earth. Okay, 1 joule is equal to 10 power 7 earth. So the answer is option B. So the answer is option B. And coming to the next one, 1 calorie is equal to dash joules. 1 calorie is equal to dash joules. Calorie is the bigger unit for energy or work. So 1 calorie is equal to 4.18 joules or 4.2 joules approximately. So the answer is option B. So the answer is option B. Okay, students. Next question. The capacity to do the work is dash. What is the capacity to do the work? Capacity to do the work is nothing but energy. That is nothing but energy. And energy units are also, we know very well, joules. Energy units are also, we know very well, joules. And rate of doing work. What is the rate of doing work? So many students confused in this capacity to do the work, rate of doing work. Okay, so here power is equal to rate. Rate means time. Okay, rate means time. Rate of doing work. Work by time. Okay, work by time. And units are work units, joule per second or watt. All of you try to understand. Capacity to do the work is energy. Work is energy. That means if we have more energy, then we can do more work. We can do more work. That is the meaning. Okay, if we have more energy, we can do the more work. Okay, if you want to do any work, then we can do double, triple also if we have the more energy. Okay, and if we have the more power, if we have the more power, power is more. Power is equal to work done by time. If we have the more power, we can complete that one with a very less time. Okay, if we have more power, we can complete faster rate. We can complete faster rate. All of you clear? That is a simple understanding. More energy, we can do more work. If we have more power, we can complete the work faster. For example, if you want to deliver 1000 liter from any one pump, okay, from any one pump, if you are going for half HP of the power, it may take nearly 30 minutes if you can consider. If you go for 2 horsepower, it may be complete within 10 minutes. Within 10 minutes. Okay, so that means higher the power rating, we can complete faster. We can complete the work faster. Okay, so if you can consider for the same work, if the work is same, more power, less time consumption. Less time consumption. That is the difference. Okay, so rate of doing rate means time. Rate of doing work by time. That is nothing but power. That is nothing but power. Coming to the next one, guys. Energy possessed by an object by position or configuration is called as dash. By position or configuration is called as dash. Here, generally, the mechanical energy is sum of potential energy plus kinetic energy. It is the not divided, friends, sum of potential energy plus kinetic energy. Okay, so potential energy, if you are getting the energy by potential, that is by position or configuration, by configure in a particular manner, position, configuration, or elasticity. If you are getting the energy by virtue of its position or configuration or elasticity, we can say that is a potential energy. Okay, and this potential energy is equal to mgh. A simple idea, friends, a simple idea. Wherever there is a h term is there, that is belongs to potential energy. Okay, so h term, height, head, depth, whatever it may be, wherever there is a h term, that is you can say it is a potential energy. For example, if anyone having certain height, so due to the height it is getting energy, so it is a potential energy. For example, if the ball is on the surface, it don't have any energy. If the ball is going to any certain height, it may having the energy. Okay, and after that it is going to be fall. Whenever it is movement, whenever this ball is movement, that potential energy is going to be converted into kinetic energy. Okay, so that means whenever there is a movement, whenever there is a motion, that is whenever there is a velocity, whenever there is a speed or velocity or motion, whatever they have given. Okay, so then that is having kinetic energy of mv square. Okay, so that means wherever there is a v term is there, we can go for that is a kinetic energy. And according to energy conservation, law of energy conservation, energy neither be created nor be destroyed. It transforms from one form to another form, either potential energy to kinetic or kinetic to potential. Okay, here by position or configuration, asking simple question, potential energy only. All of you note down this one. Okay, coming to the next one, guys. Horsepower is the unit of action. As the name itself we have horsepower. Horsepower. It is unit of mechanical power. Mechanical power. Okay. Mechanical work units are joules. Energy units are also joules. Electrical energy kilowatt hour. Okay. So the answer is mechanical power. Answer is option B. Coming to the next one, guys. Water stored in reservoir having dash type of energy. Water stored in reservoir having dash type of energy. Just now I have given, if you are getting the energy by virtue of its position, if you are storing the water in any tank, or if you are storing the water in any reservoir, whatever it may be. So you are creating the position, you are creating the height of the water. Okay, due to this height or due to this position, you are getting the energy. That is the potential energy. Okay, and whenever you release it, water is moving. So now water is having motion, velocity. Whenever it is having the velocity, then it is going to be kinetic energy. Kinetic energy. That means here potential energy is converted into kinetic energy. Converted into kinetic energy. So we have already discussed the law of conservation of energy. Energy neither be created nor be destroyed and transformed from one form to another form. Okay. So here stored water, we are creating the storing. So that means potential energy. If they are asking running water in river, that is something we can say kinetic energy. Okay. Coming to the next one, guys. Stretched rubber having dash type of energy. Stretched rubber having dash type of energy. Stretched rubber, that is elasticity. Elasticity means potential energy. Potential energy. Coming to the next one. A raised hammer. For example, a hammer is on the earth's surface. It don't have any energy. And whenever you are raising the hammer, then it is the sum of the height is created. Whenever there is a height is created, then that is a potential energy. Given now, so it is a potential energy. Potential energy. Coming to the next one, guys. Compressed spring possesses more energy than a spring of normal length because the compressed spring, you are creating the position, you are configuring as the compression, as the compressed spring. Okay, so there is configuration or position that is belongs to potential energy. So the answer is option B. Coming to the next one, guys. Potential energy is given by dash. Just now I have given potential energy is equal to mgh. So the answer is option A. Okay, and energy stored in dry cell is in the form of dash. Energy stored in dry cell is in the form of dash. Dry cell is nothing we can say battery. Battery. So in the batteries we have the chemicals, for example, lithium ion battery, lithium polymer. Okay, so that means in case of this dry cell we have the chemical energy. Okay, not only dry cells, liquid cells also we have the chemicals only. Okay, so in the batteries we have the chemical energy that will be converted into electrical energy. Okay, questions. A ball falling from height of h, after it has fallen to h by 2, then it possesses which energy? Then it possesses dash. In the following, which of the following is correct? Here they have given a ball from height of h, is let us take height of h, has fallen to h by 2. Then it possesses dash. Here at the top, because of this height, we have the potential energy because of mgh. Okay, and at this maximum height, the final velocity is 0, so kinetic energy is 0. And whenever it starts moving, what is happening? Height will becomes off. Whenever the height is off, then potential energy also going to be off now. mgh by 2, that is equal to p by 2. Okay, potential energy is going to be off. And as per the law of conservation of energy, energy neither be created nor be destroyed. It will transform from one form to another form. So this potential energy is going to be transformed to kinetic energy. It is also going to be off. Okay, from 0 to off. And at this point, potential energy is 0 and kinetic energy is equal to maximum. Okay, so that means at half of the height, the kinetic energy is going to be off and potential energy also going to be off. Off potential energy and off kinetic energy. At maximum height, as the final velocity is 0, kinetic energy also 0. Okay, as this initial point on the earth surface, as the height is 0, potential energy is 0. Okay, so at half of the height we have both. If you can consider at this one, that is at this 3 by 4th of the height, in this point potential energy is maybe higher, maybe high, and kinetic energy is somewhat of less. Okay, so here kinetic energy is 1 by 4th, potential energy is 3 by 4th. At this point, kinetic energy is 3 by 4th and potential energy is 1 by 4th. As the height decreases, the potential energy also decreases. At any point, the total energy is constant. At any point, the total energy is constant. 3 by 4 plus 1 by 4, 1. 1 by 2 plus 1 by 2, 1. 3 by 4 plus 1 by 4, 1. So 0 plus maximum, 0 plus 1, 1. Okay. When a body freely falls towards the air, then its total energy is dash. Just now I have given. its total energy is always constant. It remains constant. Okay, coming to the next one. Bullet coming from gun having dash type of energy. Here, let us take bullet coming from the gun. Here, bullet coming from the gun having the velocity. It has the momentum, that means it is having the velocity. Whenever it is having the velocity or speed, then we have the kinetic energy, that is half mv square. Answer is the option B. Coming to the next one. A 30 kg mass falls through a height of 500 centimeter, then find the potential energy lost by the mass and kinetic energy is gained by the respectively dash joules. A very easy question. Here they are asking potential energy loss and kinetic energy gain. Just now I have given, as per the law of conservation of energy, energy neither be created nor be destroyed, transformed from one form to another form. So whatever the loss by potential, that is gained by kinetic. Whatever the loss by potential, that is gained by kinetic. So potential energy loss is equal to gain by kinetic energy now. If it is losing 500 joules, it may gains 500 joules. Okay, like for example, at this particular height, we have potential energy is 1000 joules and kinetic energy is 0 joules. Why? Because it is velocity is 0. So whenever at half of the height, what is happening? Both will be off, 500 and 500. Potential energy 500, kinetic energy 500. And at this place, potential energy 0, kinetic energy is 1000. So that means what you can understand? Potential energy loss in this half of the height, and 1000 to 500 means 500 loss. It is gained by 0 to 500 means 500 gain. So according to this one, potential energy loss is equal to kinetic energy gain. So that means both options must be same in the following. In the following options, which having the same values, that is nothing but option A having the same. So can do the answer as simply as option A. Or if you want to calculate, you can calculate the potential energy mgh. Mass G is 9.8. And we have to convert this one into meters, 5 meters. So that is nothing but we are getting 1470 joules. So the potential energy loss is equal to kinetic energy gain, both are 1470. Coming to the next one, Mohan having a mass of 40 kg runs a staircase of 50 steps in 10 seconds. If the height of each step is 15 centimeter, then what is his power? What is his power? Here we know the power formula now. Power is equal to rate of doing work or energy by time. Here which type of energy they have given the height. Height given means potential energy now by time. Potential energy mgh by time. Mass is 40 kg. G they have given as 10 and height. Each step of 15 centimeter and those type of steps we have 50. 50 into 15 centimeter, 750 centimeter. That means 7.5 meter. 7.5 meter by time. Time is nothing but 10 seconds they have given. So 7.75 into 4 is 300. 300 watts. Power units are watts. So the answer is option A. So the answer is option A. Coming to the next one, students. An object is thrown vertically upwards and reaches to the maximum height h from the ground. During its flight and reaching 3/4 of the height, it will acquire dash. We have already done this one also. If you throw any ball vertically upwards, it reaches to the maximum height h. Okay, so if you can consider h by 2, it is 3/4 of the height. At this one, what is happening? Potential energy is more now. Potential energy is more and kinetic energy is less. Okay, it is 3/4 of the potential, it is 1/4 of the kinetic. Okay, so more potential and less kinetic energy, you can give the answer as option B. We can give the answer as option B. Coming to the next one, which of the following is not the unit of energy? Which of the following is not unit of the energy? Energy. Here coming to the kilowatt, kilowatt is the unit of electric power. And kilowatt hour electrical energy. Joule is mechanical energy and Newton meter also energy only. Why? Because here 1 joule is equal to 1 Newton meter. We know work is equal to force into displacement. Force Newton displacement meter. So work units are joules. So 1 joule is equal to 1 Newton meter. So it is also unit, but it is the unit of power, not energy. So can you the answer as option A. Okay, so let us start the session. Our planet Earth receives or transfers most of its energy in the form of dash. We know very well our Earth receives the energy from the sun through radiation process, and that energy is considered as radiant energy. Okay, so can you the answer as option A. Coming to the next one, a body of 2 kg lying at rest. Under the action of constant force, it gains the speed of 10 meter per second. The work done by the force will be dash. Here, all of you remember one important thing. Whenever they are giving work done by this force, is nothing but can say that is the energy, guys. Okay, here we have to find out which type of which energy it is. I mean, potential energy or kinetic energy. How to get idea? If they have given height term mgh, height term, then we can say simply due to the height we are getting potential energy. If they have given velocity, they have given velocity or speed, then you can say that is the kinetic energy. Okay, so like that we can easily identify. Here they have given the speed now, so it is a kinetic energy. So kinetic energy is equal to half m v square. If we have two velocities, we can say v square minus u square. Okay, v square minus u square. Here let us take half into mass is 2 kg and v velocity is 10 square. 2 is getting cancelled out, 10 square is 100 joules. So the answer is option C. Coming to the next one, guys. Relationship between kinetic energy and momentum is given by dash. Relationship between kinetic energy and momentum. We know the formulas of the kinetic energy, that is equal to half mv square, and momentum mass into velocity. Mass into velocity. Here in this also we have mv. Here in this also we have, but v square we have. For that to get the v square, I am squaring on both sides. But we want only one mv square, so I am sending one m to this side, then mv square. So and now in this equation you can substitute in the place of mv square p square by m. So now you are getting k is equal to p square by 2m. K is equal to p square by 2m. So the answer is option A. K is equal to p square by 2m. Coming to the next one, guys. So the value of the momentum for a particle is numerically equal to its kinetic energy. Then what will be the velocity of that particle is dash. What will be the velocity of that particle is dash. Here what I have given momentum is numerically equal to kinetic energy. Then its velocity of that particle. Momentum formula mv, kinetic energy mv square. So substitute cancel out this m and m, 1v and 1v. Then you are having 1 by 2 into v. So from this v is equal to 2 meter per second. 2 meter per second. So the answer is option B. So the answer is option B. So if the velocity, the momentum is equal to kinetic energy, then velocity may be 2 meter per second. Coming to the next one. If the momentum for a particle is numerically increased by 10%, then it is increases by, then its kinetic energy is increased by dash percentage. Here just now we have discussed the relation between K and momentum, P square by 2m. If you can consider same particle, m is constant, 2 is constant, then we have the relation K proportional to P square. So the momentum is increased by 10%. You can make it as 1.1 of the P. 1.1 of the P, that means 10% increment. So now K proportional to 1.1 of the P whole square. That is 1.21 of the P square. 1.21 means 21% increment. 21% increment. So K is increased by 21%. Okay. So 10% increment means 21% increment in the kinetic energy. Kinetic energy because of the square relation. Square relation. Okay. Coming to the next one, guys. The two objects of masses 1 kg and 4 kg have the equal momentum. What is the ratio of their kinetic energies is dash? What is the ratio of their kinetic energies is dash? Here masses m1 is to m2 given as 1 is to 4 and asking kinetic energy relation. Is there any relation between kinetic energy and masses? We know K is equal to P square by 2m. Here equal momentum means P is constant and 2 also constant, then K is inversely proportional to the mass. inversely proportional to the mass. So m1 is to m2 is equal to 1 is to 4. Then kinetic energy inversely proportional means opposite, reciprocal. 4 is to 1. So 4 is to 1 means you can give the answer as option B. Okay. An object having a mass m and moving with velocity v and possesses a kinetic energy k. If its velocity is double, what happened to the kinetic energy? So we know very well the kinetic energy formula. In the previous classes I have given na half mv square, that is nothing but k they have given. Okay, that is equal to k. If the velocity is going to be double, what happened to the kinetic energy? Okay, so if the velocity is going to be double, let us take that velocity is going to be double, 2v whole square na, 2v whole square. So in this you can take as half into m into b square. This 2 square means 4, and this half mv square again you can take it as k. Now 4 into k. So the kinetic energy will becomes 4 times. Kinetic energy will becomes 4 times. Here k is directly proportional to v square, square relation. Now if the v is going to be 2v, then kinetic energy will becomes 4 into k or 4 into k. Okay, so it will becomes 4k. Coming to the next one, guys, the rate of change of velocity is called as dash. Very easy question. The rate of change of velocity is called as dash. That is nothing but acceleration. Na? Generally, rate of displacement, that means change in displacement. The velocity is nothing but change in displacement by time. Okay, change in displacement by time. And in the same way, acceleration is equal to, denoted as a change in velocity with respect to time. Change in velocity with respect to time. So rate of change of velocity. Okay, if we have final velocity is v, initial velocity is u by t. So that is nothing but acceleration. Velocity meter per second times second. So meter per second square is the unit. Meter per second square is the unit. Okay, so the rate of change of velocity is nothing but can say acceleration, that is meter per second square. Coming to the next one, the slope of a distance time graph shows dash. Slope of distance time. So if we can consider, this is the time, this is the distance. Okay, so as the time varies, distance varies, then this is nothing but can say slope na. So d, it is the t. So slope is nothing but y-axis by x-axis, distance by time. So distance by time is nothing but can say speed na. Speed, we know speed is equal to slope of distance and time curve. So that is nothing but distance by time. Units are meter per second. Okay, speed. If they have given displacement and time, displacement time graph gives the velocity. Okay, it is the vector term, it is the scalar term. So these velocity units are also meter per second. Coming to the next one, slope of velocity time. Velocity time. So if you draw the curve with the velocity and the time, so as the time varies, the velocity also going to be varies. Okay, so it is v and by t. Slope is nothing but y-axis by x-axis, v by t. V by t. Okay, so v by t means you can say acceleration. Na? Change in velocity with respect to the time is the acceleration. The acceleration. Okay, velocity time graph gives the acceleration, or acceleration is equal to velocity with respect to the time. Physical unit, physical quantity jerk unit. What is meant by jerk? Here velocity is equal to displacement by time. Acceleration is equal to change in this velocity by time. In the same way, jerk is equal to this change in acceleration, dA by dt. Change in the acceleration. So the sudden change in the acceleration can say jerk. So units are nothing but acceleration, meter per second square by second. So meter per second cube. Meter per second cube. So the answer is option B. Meter per second cube. So the answer is option B. Coming to the next one, guys. Acceleration is a vector quantity which indicates that its value is dash. It is a vector quantity, and we know the acceleration may be positive, negative and zero. If it is a standstill, Okay, any body is at rest, you can say 0. Okay, so if the velocity is decreasing with respect to the time, that is negative acceleration. If the velocity is increasing with respect to the time, that is the positive. So can be positive, negative or 0. Coming to the next one, units of acceleration just now have given meter per second square. And if the ball is thrown up, which of the following does not change? So if I am going to throw a ball upward side. Okay, so if I am throwing a ball in upward side, then what is happening? Height increases. Height increases. So height increases means potential energy increases. So potential energy changes. And distance. Distance means the path traveled by the body. So distance also changes. And what about the speed or velocity? Whenever it reaches to the maximum speed, maximum height, velocity is 0. It is also change. And what about the acceleration? Acceleration is constant acceleration. Upward side minus g. And downward side a is equal to plus g. It is a fixed value 9.8 meter per second square. Okay, so the acceleration is the constant and also total energy. Total energy also constant. Coming to the next one, guys. Acceleration due to the gravity value generally dash. Generally, it is a value is 9.8 meter per second square. Sometimes approximately 10 meter per second square also we will take in the numericals for easy calculation. Okay. If the initial velocity of a car is 5 meter per second and the final velocity is 10 meter per second in 5 seconds, then what is the acceleration? What is the acceleration? I have already given in the previous, acceleration is equal to change in velocity with respect to the time. Okay, change in velocity means final velocity minus initial velocity by time. So final velocity is nothing but v is equal to 10 given, and initial velocity u is equal to 5 given. So substitute 10 minus 5, and what is the time? 5 seconds, within 5 seconds. So 5 by 5, that is equal to 1. That is equal to 1. So acceleration is equal to 1 meter per second square. 1 meter per second square. So coming to the next one, guys. What is the formula for weight of an object of mass and where g is the acceleration due to gravity? Where g is the acceleration due to gravity. We know very well mass is a constant at everywhere. Constant at everywhere. Constant value in everywhere. But coming to the weight may be different. So weight is equal to mass into acceleration due to gravity. So gravity changes from place to place. Changes from place to place. So that's why weight will be changes. Okay. So weight is equal to product of mass into acceleration due to gravity. Coming to the next one, guys. A force increase the speed of 1 kg mass of object from 2 meter per second to 6 meter per second. Then work done by the force will be dash. Okay, I have already given in the previous, work done by the force is nothing but energy. So we have to find out which type of energy it is. Given speed means kinetic energy. Okay, so change in kinetic energy, that is half into m into two velocities are there, final velocity, initial velocity. So change in those, v square minus u square. So that is half into m, mass is 1, v square 6 square minus 2 square. Okay, so in the Hindi 2 and 6. So 6 square 36 minus 4 32 by 2. So that is nothing but 16. 16. So the answer is option B. 16. So the answer is option B. Coming to the next one, guys. A man lifts a luggage of 25 kg from the ground and puts it on the head 2.5 meter above from the ground. The value of g is equal to 10 meter per second square. Then the value of the work done by him on the luggage is dash. On the luggage is dash. Okay. So the work done by him on the luggage. Work done is nothing but energy. Which type of energy, guys, here? They have given head or height. Height, head given means that is a potential energy. Na? M G H. So what is the mass? 25. G they have given 10. H is 2.5 meter. Already meter given, so no need of worry. 25 into 10 into 2.5, 25. 25 square, 625. 625. So the answer is option C. Coming to the next one, guys. A machine gun fires 240 bullets per minute If the mass of each bullet is 10 grams and the velocity of the bullets is 600 meter per second, then the power of gun in kilowatts. We know the power is nothing but work done by energy or work by time or energy by time. Which energy here? Speed given means kinetic energy. So kinetic energy by time. So total kinetic energy. So kinetic energy is half mv square. But here we have so many bullets. So number of bullets. So n into half mv square by time. So one bullet kinetic energy is half mv square. So total 240 bullets given na. So 240 into that kinetic energy mass given in the ground. So we have to convert it into kgs. So mass I have taken velocity directly meter per second given. So no need to convert by the time t. So per minute given na per minute, that is take as 60. 60 ones, 60 tens. Okay, and 2 ones, 2 120s, 2 120s. So 12 into 6 72, and 1 0, 2 zeros and 3 zeros is 10 power minus 3 getting cancelled out. Remaining 2 zeros. 7200 watts or 7.2 kilowatts. 7.2 kilowatts means, so the answer is option D. Na? So the answer is option D. Coming to the next one, guys. Same type of the question, but here they are asking, find out the maximum bullets per minute. A machine gun fires a bullet of mass 50 grams and velocity 1000 meter per second. If the average force acting on the gun is 200 newtons, then the number of bullets fired per minute. So whenever the machine gun fires, it will have the momentum. Okay, and also whenever we fire the bullet, machine gun fires that bullet with having very high amount of the force within very short time. So high amount of the force within a short time, that is nothing but you can say impulsive force. So it is also having the impulse. That change in momentum is nothing but impulse. So the momentum is P is equal to impulsive force now. Okay, so change in momentum is nothing but, for example, if we have n number of bullets, n into P is equal to impulse force. Okay, so n into m into v, impulse force into time. So now the number of bullets are nothing but f into time by mass into velocity. That is the final formula. So you can remember this formula directly and no need to derive in the examination. So force given 200 and time given as per minute, so 60 by mass is 50 into 10 power minus 3 and velocity is 1000. 1000 10 power minus 3, 51, 54. So that is nothing but 240 bullets. So the number of bullets fired are nothing but 240. The number of bullets fired is nothing but 240. Okay, coming to the next one, guys. Here also they have given the power of gun. Just now we have done this power of gun, energy by time, total kinetic energy by time. Okay, so if they have given number of bullets, n into half mv square by time now. So number of bullets 360 given, half into what is the mass, 20 grams. We have to convert it into kgs. And velocity is in meter per second, but kilometer per hour given. So how to convert? We have to multiply with 5 by 18. So that means you are having 100 meter per second. So 100 into 100 by the time per minute now. Yes, 60. Okay, 60. So 60 ones, 66 and 2 ones, 2 tens. 1 0, 2 0, 3 zeros and 10 power minus 3 is cancelled out. 600 into 100, 600. So 600 watt. Okay. So like that you can get the answer. So the formulas are very, very important for numericals. And this type of questions are very important in NTPC, CBT type and also group D examination. Okay. A person lifts luggage of 20 kg from the ground and put it on his head 2 meters above from the ground. Calculate the work done by him. In the previous session, I have given about what is the work done. Work done is nothing but energy. So here we have to find out which type of energy. So whenever they have given height, You can say that is a potential energy now. Whenever they have given velocity, that is a kinetic energy. mgh. Mass in kg, g is meter per second square, and the height given in meters only. Okay, if they have given centimeters, converts into a meter. So that means you are getting 400 joules. Okay. So the answer is option D. Coming to the next one, guys. A 400 kg car is moving at a speed of 90 km per hour. It takes 5 seconds to stop after the brakes are applied. The force applied to the brake is dash. The force applied to the brake is dash. It is a very simple question. What is the force formula as per the Newton's second law? F is equal to m into a. So that means we need to find out the acceleration and we have to substitute the mass. Okay. So it takes 5 seconds to stop and the speed given as 90 km per hour. So we know very well acceleration is equal to dv by dt or v by t. Okay, so here what is the v they have given? So 90 km per hour. So 90 km, if we convert this into meter per second, so you can get 5 by 18. By time is 5 seconds. 18 once, 18 5. So 1515. So you are getting acceleration as 5. So that means mass is 400 kg and acceleration is equal to 5. So that is nothing but 2000 newtons. So the answer is option B. 2000 newtons. So the answer is option B. Coming to the next one, guys. Physical quantities which have dash only and no dash are called as scalar quantities. Here, coming to the scalar and vector, this is a very, very important point, very important topic. And coming to the scalar and vector, here coming to the scalar case, the quantities which have only magnitude, but not direction, You can say those are scalar quantities. Coming to the vector quantities, both quantities having both magnitude and also direction. Those are nothing but you can say vector quantities. For example, if you can consider distance, distance may not depend upon the direction. So distance is a scalar. In the same way, displacement depends upon the direction. So it is a vector quantity. If the distance is the scalar, then coming to the speed is equal to distance by time. So it is a scalar. Here velocity, okay, displacement by time. So and velocity is there means acceleration also. Acceleration if we have means force also. Why? Because F is equal to m into a. Here other example, work, power, energy are scalar quantities, and also can say pressure, the exceptional case pressure also scalar quantity because it having in every direction. So it may not depend upon the particular direction. Okay, particular direction. So all these are scalar, all these are vector. Okay, here which is having dash only, magnitude only, but no direction. So the answer is option B now. So magnitude only, but not the direction. Coming to the next one. Which among the following is false about the work? Which among the following is false about the work? Let us take the first option A. Displacement is 0 when what about the work done? Work done is equal to force into displacement. And this displacement is 0, work done also 0. So it is correct only. Work can be negative, yes, work done is can be negative. Why? Because W is equal to Fs cos theta. If the cos theta value is -1, cos theta value is -1, then you are getting work is negative. Okay, and after that you can say it is a vector quantity. No, but it is a scalar quantity. It is a scalar quantity, and units of work is nothing but can say joule. It is also correct. Okay, it is also correct. So then what will be the answer? You can say it is a vector quantity is the false one. Coming to the next one, guys. Which among the following are scalar quantities? Just now I have given scalar quantities. Here speed, yes, scalar quantity now. Distance by time. So it is the scalar quantity. And remaining acceleration, velocity, and displacement. Displacement is a vector. Change in displacement, velocity. That is also vector. Change in velocity, that is acceleration. That is also vector. So all are depends on the direction. So these three are coming to vector quantities. Newton's first law of motion give the concept of dash. Newton's first law of the motion will give the concept of force or law of inertia. Law of inertia. That means any object, it is opposes the sudden change in position. Opposes the sudden change in position. That is something we can say inertia. So if you want to understand about inertia in a simple manner, let us take a fan is the example. Fan is the example. Here, if you switch on the fan, then fan starts rotating. Okay, so whenever you switch on the fan starts rotating. And whenever the fan starts rotating, it is rotating. And if you are going to switch off, then what is happening? After switching off also, sometimes fan is rotating and the speed is gradually decreasing and it comes to the rest position. Why? Because in the air we have the friction is there. That means here the position is there for the movement, for the fan movement. So that means due to that one it is going to be stop. So that means whenever you switch off, the fan is not going to be switched off. That is, fan is rotating only. Okay, supply is switched off, but still the fan is rotating. So because of that inertia, so it is previous, it is in moving direction now. Suddenly you are giving the switch off in the supply also, then it is continuously moving because of the inertia. That is nothing more can say inertia. Okay, the tendency of undisturbed object to stay at rest or to keep moving with the same velocity. That is nothing but just now we have discussed. That is nothing we can say inertia. In Hindi you can say jadatva. Okay, so the tendency of undisturbed object to stay rest. That means if any object is at rest, it is always on the rest. If any object is in moving, that is always it's in moving until unless if you apply any external thing. Okay, so that is something we can say inertia. That external thing is something we can say force. That external thing is something we can say force. Okay. Newton's which law will give the magnitude of force? Newton's which law will give the magnitude of force? I have already given about the first law. First law will give the definition of the force. Definition of force. That is nothing we can say law of inertia. Law of inertia. And coming to the second law. So in the second law, there is nothing but given the magnitude of the force. Magnitude of force. F is equal to m into a. And coming to the third law, already two laws given now. By how to left this third law. For every action, there is equal and opposite reaction. For every action, there is equal and opposite reaction. So F1 is equal to minus F2. For every action, there is equal and opposite reaction. So these are the three important laws of the Newton's. Okay. So magnitude asking means second law only. So we can give the answer as option B. Coming to the next one, guys. Rate of change of momentum is dash. Rate of change of momentum is dash. What is this momentum? Momentum is denoted with the P, that is nothing but mass into velocity. Rate of change. So rate of change means differentiation with respect to time. So if you differentiate with respect to the time means dp by dt, that is the rate of momentum. So if you differentiate this mass into velocity, okay, so mass is a constant in dv by dt. dv by dt is the acceleration, m into a, okay, so m into a. So that means you can say m into a is nothing but you can say force. So you can say rate of change of momentum is nothing but force. The rate of change of momentum is nothing but you can say force. So the answer is option C. Coming to the next one, guys. Which of these equals the impulse applied? Which of these equals the impulse applied? Okay. So what is the impulse applied? Impulse is nothing but impulsive force. Is nothing but force into time. Force into time. Impulse is nothing but force into time. Okay, so F into T, F into T. So change in momentum, change in force, change in velocity, change in acceleration. How to get this impulse? So let us take a change in momentum. P is equal to mass into velocity. If you are going to change with respect to time, dp by dt is equal to dp by dt is equal to, let us take that in the next step. Dp by dt is equal to m into dv by dt. So v is the variable, so I am differentiating that one. So dv by dt is equal to m into dv by dt is nothing but a. So now dp is equal to m into a means force, and this dt comes here, dt. So that means here we can say f into t is nothing but we can say impulse. Now impulse is nothing but change in momentum. Now dp means change in momentum. Okay, so impulse applied is nothing but change in momentum. So the answer is option A. So the answer is option A. Coming to the next one, guys. What will be the force of attraction between the two bodies weighing 40 kg and 100 kg respectively, with a distance of 2 meters between them? With a distance of 2 meters between them. Here we know very well the force of attraction equation. Okay, so whenever we have the two masses, m1, m2, those are displaced with a distance d, then force is directly proportional to product of those masses by the distance square. If you remove the proportionality constant, you will get g into m1 m2 by d square. Okay, so if you substitute that g is nothing but 6.67 into 10 power minus 11 into m1 into m2. So m1 is 40 kg, m2 is 100 kg, by distance d is 2 meters. So 2 square means 4, you are getting 4 ones, 4 tens. 1 0, 2 0, 3 zeros. 3 zeros means 10 power minus 8. Okay, so that means you are getting 6.67 into 10 power minus 8 newtons. So the answer is option D. So the answer is option D. Coming to the next one, guys. A constant force acts on a body of mass 500 grams at rest. If in 5 seconds the body moves a distance of 200 meters, then what is the magnitude of force? What is the magnitude of force? We know the magnitude of force. Force is equal to m into a. But here we require a. So in the motion, the three equations of the motion we have v is equal to u plus at. Second one s is equal to ut plus half at square. Okay, and the third one v square minus u square is equal to 2as. V square minus u square is equal to 2as. So these are the three equations we have. In this one, from which equation you can get the acceleration in this case? So here they have given distance or displacement and time also given, and at rest they have given rest. Rest means what about the initial velocity is 0. So if you want to use this first equation and third equation, we require the final velocity, but we don't have the final velocity. So it is better to go with the option 2, that is the second equation of the motion, s is equal to ut plus half at square. So from that one, ut plus half at square. So at rest means u tends to 0. So then s is equal to half at square only. Substitute the values. S is 200, half acceleration a. We need to find out, and the time. Time they have given 5 seconds, that is 25. 5 square means 25. 8. So a is equal to 16. After that, 500 grams means 0.5 kg into a means 16. So half of the 16 is nothing, we can say 8. 8 newtons. So the answer is option B. 8 newtons. So the answer is option B. So like that we can get the answer easily. Coming to the next one, guys. While catching a ball, a player pulls down his hands to lower the net. So while catching the ball, the player pulls down his hands in the same direction of the ball. So in the same direction of the ball, we have the momentum, both mass and velocity. So we have to lower the momentum. So the answer is option B. So the answer is option B. Distance depends on only magnitude, but not direction. And displacement, both magnitude and direction. So distance is the scalar quantity and displacement is the vector quantity. So the answer is option A. Okay. What is meant by scalar? Which depends only on magnitude. Only on magnitude. Magnitude means value. Vector quantity is nothing but depends both magnitude and direction. Both magnitude and direction. Okay. Coming to the next one. In which of the following cases of the motion, distance moved and magnitude of displacement are equal? We know distance is nothing but total path covered by body. Okay, and what about the displacement? It is the shortest distance. Shortest distance from initial to final. From initial to final. Okay, so here in which case both distance and displacement are equal. In case of straight line motion. Straight line motion, what is happening? For example, between the A and B, we have 10 kilometers. This straight line only the shortest path. So distance is nothing but if any object moves from A to B means distance is 10. And what about the displacement? What about the displacement? This straight line only the shortest path. If you can consider any other path, that may be a longer. So shortest path is A to B only. So displacement also 10. So it is 10 kilometer. It is also 10 kilometers. So both are equal. So in case of straight line motion, the car is moving on straight road. The car is moving on straight road. Both the distance and displacement are equal. A particle is moving in a circular path of radius r. The displacement after half cycle would be dash. Let us take with a radius of r one circular path. One circular path. Okay. One circular path. Yes. Here any object starting from A and reaches to half of the cycle. So in the circular manner it starts rotating and reaches to the point B. Then what is the displacement? First of all, consider distance. Distance is nothing but total path covered by the body. The body is moving this path and reaches to the half of the cycle. So total circumference is nothing but 2 pi r. It is half of the circle means 2 pi r by half. That is pi into r is the distance. And what about the displacement? Displacement is the shortest distance from initial to final. This is the initial, final is the B. So initial to final we have shortest path means this is only. So this is radius r, this is radius r. Okay, r plus r, that is 2r. So 2r is the displacement. Pi r means 3.14 into r. So that means here what you can get, displacement is less than distance. So this is the second case. First case we have already discussed. The first case, here distance, displacement both are same. So displacement is equal to distance. From this first and second case, from 1 and 2, we can say displacement less than or equal to distance. Less than or equal to distance. Okay, so that is the final case. So here distance 3.14 or displacement is the 2. So the answer is option C. Coming to the next one. Which of the following is correct? Just now we have discussed this one. Which of the following is correct? Distance displacement relation. Displacement may be less or equal to distance. So we have to read all the options. So the final option. less than or equal to both. So we can use the answer as option D. Coming to the next one, if the distance traveled by an object is 0, then what happened to the displacement? Then what happened to the displacement? Distance is 0 they have given. Distance is 0 means it is a rest position. The body is rest. Body is standstill. It is not moving. Okay. So then we can say that is distance is 0. If it is not moving, so initial and final point both are same. Initial and final same. Initial and final same means what about the displacement? That is also 0. So we can note down the point, if distance is equal to 0, displacement also 0 only. And if displacement is equal to 0, then distance may be or may not be 0. What is the second point? For example, if any object is moving circular orbit, it starts from the A and also reaches the same point B. Reaches the same point. So initial and final points are same. So that means displacement is equal to 0. And what is the distance? Total path covered by the body. So total circumference 2 pi r. Total circumference, that is 2 pi. Okay. So if the distance traveled by an object is 0, displacement also 0. Coming to the next one. If your body is moving on a circular path, that is uniform circular, what is the average velocity if it completes one cycle in 1 second? They have given average velocity. Average velocity, that is displacement by time. So if it is in a circular path, displacement, just now I have discussed, initial and final points are same, that is 0. 0 by anything is 0. So the average velocity is 0. So the average velocity is 0. Coming to the next one, as the object covers unequal distances in equal intervals of the time, it is said to be in dash motion. So here unequal distances means you can say non-uniform. So you can give the answer as option C. You can give the answer as option C. If they have given equal distances in equal intervals of the time, that is the uniform. Okay. Equal distances in equal intervals of time. A trolley, while going down an inclined plane, has an acceleration of 2 centimeters per second square. What will be its velocity 3 seconds after the start? 3 seconds after the start. So a trolley is going inclined down. Okay, inclined down. So if it is inclined down, what may be the initial velocity? Okay, so they are asking the final velocity means after 3 seconds means final velocity. Final velocity formula V is equal to U plus AT. We have three equations of the motion. First one, final velocity is equal to U plus AT. Second one, displacement is equal to UT plus half AT square. Third one, V square minus U square is equal to 2AS. Okay, U is initial velocity. V is the final velocity. V is the final velocity. So V is equal to initial velocity is 0. Acceleration 2 centimeter per second square into time 3 seconds. So that means you are getting 6 centimeter per second. So centimeter per second is the velocity. So 6 is nothing, you can say the answer is option B. Okay. Okay. So if the displacement of an object is proportional to square of the time, then the object moves with dash. Then the object moves with a dash. Okay. Here, if the displacement is proportional to the square of the time, yes, proportional to square of the time, then the object moves with a dash. So here we have the relation S is equal to UT plus half AT square. This is the displacement. Am I correct? This is the displacement we have. In this case, if the initial velocity is equal to 0, then S is equal to half AT square. Okay, here half is constant. If A also constant, if A is constant, then S proportional to T square. Am I correct? If A is also constant, then S proportional to T square. So they are asking this one only. S proportional to T square. It is possible whenever A is constant. A is constant means constant acceleration, that is uniform acceleration. Uniform acceleration. Okay, so the answer is option B. So the answer is option B. Coming to the next one, guys. An object starts move from the rest with uniform acceleration if the object covers the distance s1 in 100 seconds and the distance s2 in 200 seconds, then s1 is to s2 is equal to dash. Once again, the object starts move from the rest. From the rest means initial velocity is 0 and it moves with uniform acceleration. Acceleration is equal to constant. If we have the constant acceleration, then what is the relation we have? S is equal to ut plus half at square. So in this one, u is tends to 0 means this total part is 0 and a is constant. 1 by 2 also constant. These two are constant means you are getting S proportional to T square. Okay. Just now in the previous also we have discussed. Now S1 by S2 they are asking. So S1 by S2 is equal to T1 square by T2 square. So T1 square is nothing but 100 into 100 by T2 square is nothing but 200 into 200. So 1 times 2, 1 by 2, that is 1 by 4. So 1 is to 4. So the answer is option B. So that is, you can say 1 is to 4. 1 is to 4. Coming to the next one, guys. A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after the start? What distance will it cover in 10 seconds after the start? A racing car has uniform acceleration 4 meter per second square. What distance will it cover in 10 seconds after the start? Distance means CS ut plus half at square. Okay, so here they have given has uniform acceleration what distance it covers in 10 seconds after the start. After the start means it start from the rest, that is u tends to 0. Okay, then half into acceleration is 4, t square means 10 square. So 2 ones, 2 twos, 2 into 10 square, 2 into 100, 200, 200 meters. So the answer is option B, 200 meters. So the answer is option B. Coming to the next one, guys. Find the displacement of an object of a body in 10 seconds starting from the rest with an acceleration of 20 centimeter per second square. Here also they are asking the same displacement. S is equal to ut plus at square. Okay, so in this initial velocity starting from rest means initial velocity is 0, half into acceleration is 20 centimeter per second square. So 20 centimeter per second square means you can say if you convert it into a meter, 0.2 now, 0.2 meter per second square into t square, that is nothing but 10 square. Okay, so that is nothing but half into 0.2 into 10 square means 100. So 2 ones, 2 0.1, that is nothing but you can say 10 meter. So the answer is option A. So the answer is option A. Coming to the next one, guys. If an object freely falls from a height and takes 10 seconds in reaching to the bottom, what was the height from the object of falls? If any one object is freely falling means initial velocity is 0, okay, and it reaches to the bottom, this is the bottom. So whatever the object is traveling, that is nothing but you can say displacement. That displacement is nothing but your height. So whatever the height is that height only it travels. Okay, so they are asking the height means that height is the displacement of the object. So S is equal to ut plus half at square. Okay, so starts from sorry, here they have given freely falling. Freely falling means u tends to 0, then that product also 0. A is nothing but if it is any object freely falling, A is equal to plus G. if there is any object is upward direction, that is opposite to the gravity, na? So that's why minus g. In upward direction, acceleration minus g, downward direction plus g in the same direction of the gravity. So a is equal to g, that is 10. 10 square, 2 ones, 2 fives, that is equal to 500 meter. So the answer is option B, 500 meter. So the answer is option B. Coming to the next one, guys. If a ball is thrown vertically upwards with a velocity of 40 meters per second, then what will be the magnitude of its displacement after 6 seconds? If a ball is thrown vertically upwards with a velocity, that is initial velocity 40 meters per second, and reaches to, will be the magnitude of displacement after 6 seconds. After 6 seconds they are asking. So displacement S is equal to ut plus half at square. So u they have given 40 and the time they are asking 6 plus 1 by 2. If you throw any body vertically upwards, what is the a? Minus g now. So minus 10 into t square means 36. Okay, 2 ones, 2 18s. So 240 minus 180, that is nothing but 60. Okay, so 60 is the answer. So the answer is option A. 60 is the answer. So the answer is option A. Okay. What is the angle of projection for bullet fired over a horizontal plane when horizontal range is equal to 4 times to the maximum height? Whenever the horizontal range is equal to 4 times to the maximum height. First of all, I want to give the important formulas in the projectile motion. Okay, in the projectile motion. For example, if you have any one object is thrown with an angle of theta, with the initial velocity u, it will take the circular path. It will take the circular path. Okay, it will take the, it means you can say curved path, not circular. You can say it is a curved path. It's like a curve you are getting now. Curved path. And this is nothing you can say trajectory motion. Trajectory motion. Okay, so this is nothing but you can say maximum height, h max, and this horizontal distance is said to be range. Okay, and t is the total time of flight. Total time of the flight means from starting to ending how much time it takes. Okay, now coming to the important formulas. First of all, range is equal to the initial velocity u square by g sine 2 theta, u square by g sine 2 theta. And coming to the second one, h max is equal to maximum value of the height. Okay, so h max is equal to u square by 2g sine square theta, u square by 2g sine square theta, and the t is nothing but total flight time, that is 2u by g sine theta. 2u by g sine theta. These are the three formulas we have. Range u square by g sine 2 theta, h max u square by 2g sine square theta, and t is equal to 2u by g sine theta. So here what is the case they have given? Horizontal range. Horizontal range is equal to 4 times to the maximum height. So horizontal range u square by g sine 2 theta is equal to 4 times to the maximum height, u square by 2g sine square theta. Okay, u square g getting cancelled, 2 ones 2 2's. So sine 2 theta means 2 sine theta cos theta is equal to 2 into sine square theta. So 1 sine theta is getting cancelled, 2 getting cancelled. Cos theta is equal to sine theta. That means cos by sine, tan theta is equal to 1. So theta is equal to 45. So at 45 degrees, we are getting the horizontal range. This horizontal range is equal to 4 times to the maximum height. Okay, these formulas are very important. All of you please note down. Okay, all of you please note down. And this angle of projection, projectile motion always having the curved path, that is you can also consider as a trajectory motion. If your body thrown upwards, then maximum height is given by dash. If your body thrown upwards, then what is the maximum height? If you throw any body vertically upwards, upwards, then what is the angle? Angle is equal to 90 degrees. What is the H max formula? U square by 2z sine square theta. Na? Okay, so that is U square by 2z sine square theta means sine 90 whole square. Sine 90 means 1 square, that is nothing, we can say U square by 2z. U square by 2z. So the answer is option B. Answer is option B. Coming to the next one. The motion of object under free fall is an example of dash. If any object is freely falling, if any object is freely falling means that acceleration is equal to acceleration due to gravity. So that means same acceleration, constant acceleration. We can also say that uniform acceleration. You can also say that uniform acceleration. Coming to the next one. Acceleration due to gravity is maximum at a dash and minimum at a dash respectively. So if you can consider our earth, here we have the poles, north and south poles. Okay, so at these poles we have maximum acceleration due to gravity, and these are the equators. In equators we have minimum acceleration due to gravity. Okay, so maximum at the poles, minimum at equators, so the answer is option B. Maximum at the poles and minimum at equators, so the answer is option B. Coming to the next one, guys, the value of acceleration due to gravity at a distance of 2r from the surface of the earth, then where r is the radius of the earth. So value of the acceleration due to gravity at distance of h, if you can consider a distance of any h, the formula is nothing but g into the radius by r plus h whole square. This is the formula, guys. So g into r by r plus distance is, they have given 2 into radius 2r whole square. So that is g into r by 3r whole square. So that means you can say g by 9. So the answer is option C. G by 9. So the answer is option C. Okay, coming to the next one, guys. The acceleration due to gravity of two objects having a mass m and 4m, they are on the same earth surface. Here note down the point, acceleration due to gravity depends on place. Depends on places. Okay, so maximum at poles, minimum at equators, and different in case of different planets. And also G is G on earth. In case of the moon is equal to G on earth by 6. G on earth by 6. Okay, that means it is changes from place to place. But G not depends on masses. Not depends on masses of the object. Okay, so whatever it may be the masses, m is to 4m or m is to 10m, m is to 1000m, whatever it may be, if it is the same earth surface, same place means G is constant. G constant. Constant means you can say 1:1. So the answer is option B. Constant means 1:1. So the answer is option B. Okay. Okay, students. Yes. Now coming to the next one. If universal gravitational constant value on Earth is G, then what is the value of that on the moon is dash? What is the value of that on the moon is dash? Okay. We know as the name itself, universal gravitational constant. So it is universally constant. Universally constant. Okay. So universally constant you can say. So this G value is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. Okay. Newton meter square per kg square. So here you can say G value is a constant. It is constant everywhere. That means in case of Earth is G, in case of moon also G only. Okay, so it is not changes. It is a fixed value. It is a fixed value. Okay, but small g changes. Small g, acceleration due to gravity. Acceleration due to gravity. It changes. Changes from place to place. place to place. Okay, coming to the next one. What is the product of mass of a body and its velocity is called as dash? What is the product of mass of a body and its velocity? Product of mass into velocity is nothing but can say momentum. So the answer is option B, momentum. So the answer is option B. Coming to the next one. The branch of mechanics which deals the motion is called as dash. The branch of mechanics which deals the motion is called as dash. The branch of mechanics which deals the motion is nothing but can say kinematics. It is nothing but can say kinematics. So the answer is option B. Coming to the next one. When a running horse stops suddenly, the rider bends forward according to which Newton's law? According to which Newton's law? Okay, so let us understand this one. A running horse is there. Okay, so let us take this is a running horse. You can say upon this running horse, it is very difficult to draw now. So I don't want to draw this running horse. Okay, so instead of running horse, I want to take just here it is nothing but going to say a running horse. Okay, so upon this we have the rider. We have the rider. So when running horse stops suddenly, what happened to the rider? Bending forward. Why it is happening? Here horse is moving, person also moving. Am I correct? Both are moving. If the running horse stops suddenly, the running horse stops suddenly. So before both are moving now. So due to inertia, already it is in the movement condition now. Both are moving means the person and horse both are moving in this direction. So suddenly if you the horse stops, but that person may not stop suddenly. So he is trying to get its previous position. What is the previous position? Moving position. So he is trying to get the previous position, that is moving position. He is bending forward. Okay, he is bends forward. So that is nothing but according to Newton's law of inertia, that is nothing but first law. Okay, according to Newton's first law, whenever the running horse stops suddenly, the rider bends forward. In case of running bus, if you have a running bus, sorry, bus is in standstill. The bus is in rest position and the bus starts suddenly. Bus starts suddenly. Then what is happening? The passenger bends backward. Okay, that is also due to inertia. Why? Because for example, the person is sitting on the seat of in the bus. Okay, so bus is in the position, person is also in the position. So but bus is moving suddenly. Okay, but the person also moving in the bus now, but the person is trying to get its previous position. Previous position means backsider. Okay, so that's why to get the previous position is bending backward. Okay, and whenever the bus takes sudden turn like this, the person is throwing outward. That is also same law of inertia. These are the examples of law of inertia, that is Newton's first law. Okay, these are very, very important for exam point of view. Coming to the next one. A passenger standing in a bus is thrown outward, then when the bus is takes sudden turn, happens due to dash. Just now I have given, that is nothing but Newton's first law, that is law of inertia of the motion. Okay, coming to the next one. On shaking or giving jerks to the branches of a tree, the fruits fall down. This happens due to which of the following phenomena? So here whenever you shaking or giving the jerks to the branches, previously the fruits are generally standstill. Okay, if you are moving, then moving like this, jerking means the fruit is coming like this. To regain its previous position is bending backward. So in this forward backward case, then it will be fall down. Okay, that is previously it is in the rest position now. So that is nothing but going to say inertia of the rest. So the following phenomenon, that is inertia of the rest. Universal gravitational constant value is given by dash. Universal gravitation constant value is given by dash. What is the universal gravitation constant value? G. G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, so 6.67 into 10 power minus 11 Newton meter square per kg square. So the answer is option A. Coming to the next one, the value of the universal gravitational constant was first of all experimentally determined by which scientist or which physicist? Very, very important question. This value of G is experimentally given by the scientist Henry Cavendish. Henry Cavendish. Okay, this is also one of the important question. And if your body thrown upwards, it reaches to the maximum height. It reaches to the maximum height. Okay, and then it falls to initial point. Then it falls to initial point. Then what is the total flight time? I have already given in the angle of projection case total flight time 2u by g sine theta. But here, what is the angle theta? 90 degrees. So t is equal to 2u by z. So that means finally what we can say? The time to reach the maximum height is nothing but t1, time of ascent, from maximum to bottom, that is time of descent. Okay, so the always this time of ascent and time of descent is equal to time of ascent and is equal to time of descent. This ascent is equal to u by z, this descent also u by z. Okay, and then total time is equal to t1 plus t2, that is equal to u by z plus u by z, that is equal to 2u by g. Okay, so we can also say that t is equal to 2 times of the t1 or 2 times of the t2. Okay, t1 is nothing but time to reach maximum height. So that means total time is equal to 2 times of the time to reach the maximum height. Okay, so that is t is equal to 2u by g. So the answer is option B. Coming to the next one, is motion of jet is based on which law? Motion of jet, we know the motion of jet is based on Newton's third law. Newton's third law. For every action, there is equal and opposite reaction. Okay, so in case of jet, here from the back side, we are getting a force is like this. If the force is that is upward, that is force is in this direction, so the rocket is moving in this direction. That is jet is moving in this direction. Okay. So Newton's third law is nothing but for every action there is equal and opposite reaction. Okay, so if you hit the ball to the wall, then it becomes back. So that is for every action there is a equal and opposite reaction. If mass of an object on the earth is 30 kg, then its mass on the moon is dash kg. It is also very repeated question, guys. Here so many students will give the answer as option D, but which is exactly wrong. Here they are asking about the mass. Mass is a constant term. Okay, mass, it is a constant everywhere. It's constant everywhere. Okay, may not changes from place to place. May not changes from place to place. Okay, but coming to weight, if they are asking about the weight, mass m, weight w. So weight w is equal to, you can say, mass into acceleration due to gravity. So but G changes from place to place. Changes from place to place. So W also changes. Okay, W also changes. Generally, as per the physics, weight units are newtons, mass units are kg. Okay, mass units are kg. So they are asking about the mass only. This is mass is a constant everywhere. On the earth is 30, on the moon also 30 kg. So the answer is option A. So the answer is option A. Coming to the next one, guys. If the weight of an object on the earth is 30 newtons, then its weight on the moon is dash. Then its weight on the moon is dash. It's very good. Weight on the moon is equal to weight on the earth by 6. 30 by 6, that is equal to 5. So the answer is option D. So the answer is option D. Coming to the next one. Who stated the law of planetary motion? Who stated the law of planetary motion? Kepler. Kepler stated that law of planetary motion. Very important one. The total flight time required the time is dash. All of you, first of all, read all the options. Okay. I have already given in the previous session t is equal to 2u by g. And t1, that is time of ascent. Time of ascent. Okay, that is time to reach the maximum height. Time to reach the maximum height. Okay, the time to reach the maximum height. And this T1 is equal to u by z, and T2 is equal to time of descent. Time of descent. So if you flight any one object, it takes a time T1 to reach the maximum height. From the maximum height, it will be falls down, and it is the time of descent T2. Okay, so the total flight time T is equal to T1 plus T2, T1 plus T2. So this T1 also u by z, T2 also u by z. So that is nothing but 2u by z you are getting. Okay, that is 2 into T1 or 2 into T2. Okay, 2 into T1 or 2 into T2. Why? Because in the place of u by z, you can place as T1 or T2. So 2 into T1 means twice the time necessary, to reach the maximum height. The time to reach that is twice the time necessary to reach the maximum height. So 2 into T1. So the answer is option C. Coming to the next one. What is the motion of projectile follows? I have already said, if you throw any body with theta angle, okay, it takes a curved path. Okay, so the answer is option B. And that motion is trajectory motion, you can say. The path followed by projectile is called as. Just now I said the path followed by the projectile is something you can say trajectory motion. Kicked or thrown balls, jumping animals, object thrown from a window are example of dash motion. Kicked or thrown balls. If you kick a ball, then it will be goes like this. Or if you throw ball also, it will be goes like this. Okay, jumping animals. Kangaroos are jumping like this. Okay, rabbits are jumping like this. So all these are nothing but having the curved path, that is, you can say projectile motion. So the answer is option A. Coming to the next one. What is the apparent weight of the person when elevator is accelerating downward? When the elevator or lift is accelerating downward, okay, so that is, then what will happen to the that is the weight, that is, you can say apparent weight. Apparent weight means you can say imaginary weight. Just what is the weight we are feeling, imaginary weight, or what is the weight we are feeling. Okay, so whenever you are in the lift and it is accelerating downwards, what do you feel? You can feel that you are losing the weight. You are losing the weight. Okay, if elevator is downwards, we are feeling we are losing the weight. Why? Because the weight and g, that is the motion and g, both are in the same direction, so we are feeling we are losing the weight. So we are losing the weight means the apparent weight of the body is less than actual weight. Okay, so it's less than the actual weight. In case of upward direction, if anyone is in the lift and it is moving upward direction, then what you are feeling? You are gaining the weight. Am I correct or not? So you can observe in the lift, gaining weight. Gaining weight means your apparent weight is greater than actual weight. Okay, greater than the actual weight in case of upward direction. In case of downward, so downward less than the actual weight. Coming to the next one. The apparent weight of the body becomes zero in which of the following cases in the elevator? The apparent weight of the body becomes zero in which of the following cases? So when the apparent weight of the body becomes zero, whenever it is whenever the lift is freely falling, whenever the lift is freely falling, or whenever any person is freely falling, whenever any object is freely falling. Okay, so whenever we are freely falling in the lift or elevator or other side also, that is from the second floor or third floor. Okay, but don't try. Okay, so if falling down like this means we are losing the total weight. Our body weight is becomes zero. We are feeling like that. When it will be happen? So during the free fall. During the free fall. When it will be free fall? Whenever there is a rope or chain of lift brakes. Lift brakes, then it will be happen. Okay, coming to the next one. The force acting on a body for a short time are called as dash. The force acting on a body for a short time are called as dash. That is nothing but we can say impulse force. Impulse force is nothing but force in a short duration or shorter time. Okay, F into T. F into T. Yes. We have to start from this one. if universal gravitational constant value on the earth is g, then what is the value on the moon is dash. So many students confuse this one and will give the answer as g by 6, which is exactly wrong. Here, as a name itself, universal constant, universally constant. It is a fixed value in universe. In case of earth is g, means in case of the moon also g only. It is not at all changed. G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, so G is a fixed value. It is not changed. But if they are asking small g, it changes. In case of the moon is nothing but g on earth by 6 reduces 1 by 6 times, it is reduces. Okay, so g is changes from place to place, changes from place to place, but capital G not changes. Coming to the next one, what is the product of mass of a body and its velocity? Product of mass into velocity is nothing we can say momentum. So the answer is option B. Momentum is equal to mass into velocity. The branch of mechanics which deals the motion is called as dash. What is the branch of mechanics which deals the motion? Motion, only movement. That is something we can say kinematics. Answer is option B. When a running horse stops suddenly, the rider bends forward. Here, whenever the running horse stops suddenly, the rider bends forward. If bus suddenly starts, then also the passenger bends backward. That is due to inertia. Due to inertia. Inertia is nothing but you can say first law of motion. So the answer is option A. So not only in this one, if you giving the jerk or shaking the branches of the tree, the fruits will be fall down. Inertia of the rest. Inertia of the rest. Okay. If the bus is moving straight forward, if it suddenly changes in this direction, in left side direction, the passenger bend right direction. Okay. That is also due to inertia. Inertia of the motion. Okay. So let us take coming to the next one. A passenger standing in a bus is thrown outward when the bus is taken sudden turn. This is happened due to dash. Just now I have given that is Newton's first law, inertia of the motion. Newton's first law, that is inertia of the motion. Yes, this question also given. On shaking or giving jerks to the branches of the tree, the fruits fall down. This happens due to which of the following phenomena? So initially those are in the rest position now. So due to sudden changes, they may be fall down. So inertia of the rest. Universal gravitational constant G value is given by just now I have given 6.67 into 10 power minus 11 Newton meter square per kg square. And the value of the universal gravitational constant was first of all experimentally determined by the scientist or physicist. It is not by Newton. Okay, so if we have the two masses m1 and m2, those are displaced with the distance d, then you can say the force between those two is equal to g into m1 m2 by r square or d square. Okay, this is the universal gravitational constant. This value experimentally given by Cavendish, Henry Cavendish. Answer is option C. Coming to the next one. If your body thrown upwards, it reaches to the maximum height and then falls to initial point, then what will be the total flight time? If you throw any one object to vertically upwards, okay, then it will reaches to the maximum height. This time is nothing but you can say time of ascent, that is equal to u by g, and from the maximum height it will be fall down, that will be u by z again. Okay, so the total flight time is equal to u by z plus u by z, that is equal to 2u by z. Okay, so we can also say that total flight time is equal to 2 times of the time to reach the maximum height, or 2 times of the time to reach the maximum height to the bottom. Okay, so we can also go with another method. We have in angle of projection t is equal to 2u by the sine theta, but in case of vertical, theta is equal to 90 degrees. So then t is equal to 2u by z. T is equal to 2u by g. So the answer is option B. So the answer is option B. Coming to the next one, motion of jet is based on which law? Motion of jet is based on which law? Here, motion of the jet is based on Newton's third law. We know for every action there is equal and opposite reaction. There is equal and opposite reaction. Okay, so motion of jet is based on this Newton's third law. Coming to the next one, guys. If mass of object on the earth is 30 kg, then its mass on the moon is dash. Its mass on the moon is dash. Here, mass is constant everywhere. T is constant everywhere. It may not changes. May not change from place to place. From place to place. But weight may be changes. Weight is equal to mass into acceleration due to gravity. Okay, so it is a constant, but g changes. So as g changes, weight also changes. Okay, but they're asking just to mass that is equal to 30 kg on the earth means on the moon also same 30 kg only. Okay, coming to the next one. They are asking the weight. Weight may be changes. Weight on the moon is equal to 8 by 6, 30 by 6, that is equal to 5. So the answer is option D. Okay. Who stated law of planetary motion? Very, very easy one. Who stated the law of planetary motion? That is Kepler. We have the Kepler's laws on the planetary motion. So the answer is option B. Coming to the next one, what is the total flight time? I have already explained in the previous session. If you throw any body upward direction, it reaches to the maximum height. This time is nothing but you can say time of ascent T1 u by z. From the maximum height to bottom, you can find out the time T2, that is u by z. Total time is equal to T1 plus T2, that is nothing but 2u by z. So 2u by z means you can say 2 times of the T1 or 2 times of the T2 now. Why? Because T1 is equal to u by z, T2 also u by z. So 2 times of the T1 means you can say twice the time necessary to reach the maximum height, or time necessary to reach from maximum height to bottom. Okay. So total time is equal to 2 times of the T1 or 2 times of the T2. The motion of projectile is follows dash. We have already discussed the projectile motion. If you throw any object with an angle of theta, it will takes the curved path. It will takes the curved path and it will reaches the H max. And this is a curved path, you can say parabolic, or we can say this motion is trajectory motion. Trajectory motion. Okay, the motion of a projectile is follows a curved path, and this one is, you can say, trajectory motion. The path followed by projectile is called as its dash. Just now I have said the path followed by projectile is a trajectory profile or trajectory motion. Kicked or thrown balls or jumping animals or objects thrown from a window are examples of dash. If you kick a ball, then it will take like this path. That is a curved path, projectile motion. Okay, so jumping animals, rabbits, kangaroos, like that. Okay, object thrown from window. If you throw any object from the window, it will take the parabolic curved path like this. So that is a projectile motion. Coming to the next one, what is the apparent weight of the person when elevator is accelerating downwards? So in case of lift or elevator, it is accelerating downwards. Accelerating downwards. So its acceleration is towards the acceleration due to gravity. The same way means you can say we are losing the weight. So I think you can imagine if you are in the lift and you are moving downwards. Okay, then what you can feel? You are feeling that you are losing the weight. That is your imaginary weight or apparent weight. Apparent weight is something we can say imaginary weight will seems to be less than that of the actual. You are feeling like that. Okay, so if lift is accelerating upward case, then you are feeling that you are gaining the weight. So apparent weight or your imaginary weight is nothing but greater than the actual weight. Okay, so here downwards case less than the actual weight. Okay, so for example, if the lift is freely falling. When it is freely falling, whenever the chain breaks, rope or chain breaks, it is freely falling. In case of freely falling case, you are feeling you are losing your total weight. Then your apparent weight will become 0. Your apparent or imaginary weight will become 0 in case of freely falling or chain the brakes. Okay. The apparent weight of a body becomes 0 in which of the following cases in the elevator? So in which of the following cases you can say during free fall of an object. Okay, coming to the next one. The force acting on a body for a short time are called as dash. What is the force in a short duration? Force into time is nothing you can say impulse. Very high amount of the force in a short time, you can say that is the impulsive force. For example, bullet coming from the gun having impulse force. Bullet coming from gun having impulsive force. So the answer is option A. Coming to the next one. The centripetal force and centrifugal forces are dash. What is the centripetal force? Centripetal towards to the center. Towards to the center. The force which is acting towards to the center is centripetal, and which is outwards. Outwards is nothing but centrifugal. Okay, for example, in the washing machine, the force is always outwards. Okay, the force is always outward. That outward force is centrifugal force. Okay, this F1 and F2 almost same magnitude, values are same, but opposite direction. So equal in magnitude, but having opposite direction. Okay, coming to the next one. So the centripetal force required to keep the moon in its orbit is provided by which force? That is the gravitational force of the earth. Because of this gravitational force of the earth, it is always keep moving in its particular orbit. What is the minimum escape velocity of rocket to be launched into the space? That is 11 km per second. If you having the speed of your rocket or your vehicle is greater than or almost equal to 11 km per second, then you can escape from the space. Okay, you can launch it into the space. The working principle of washing machine. Just now I have given that is a centrifugation, outward force from center. Outward force from the center. Okay, coming to the next one. A man presses more weight at the dash. When a man can presses more weight, whenever he is in the standing position. In the standing position, then lot of gravity will be happen on that one. So the weight is equal to mass into gravity. As the gravity will be more, weight will be more. So presses more weight on the earth whenever it is in the standing. Okay. Okay, students, we will discuss the remaining questions in the next session. All of you, thank you so much for watching. And if you want previous session, just click on the playlist and you can find out on the previous session. And if you want PDF, just click on the description box. You can find out the link for the PDF. Okay, and you can